Today we will discuss about ray optics, in which we are going to discuss the phenomena of light such as reflection, refraction and dispersion. Here, in order to trace the image formed by lenses and mirrors, we make use of some geometrical laws. Therefore, this lesson is also known as geometrical optics. First of all, let us know what are the different types of curved mirrors about which we are going to study and the lenses. See, here we have a curved mirror. You might have studied about plane mirrors in your lower class, and of course about these curved mirrors also. This is a concave mirror. You observe that here the surface is convex and here it is concave. So this is the reflecting surface. Now you can see that at some positions the image is magnified. At some positions the image formed by the mirror is diminished. Now a mirror forms images by reflection. Now you can see, let us expose to some distant object and see the image formed by the mirror by reflection. So here this is called a distance object method, and you can see the image of a distance object. So that distant object, say some tree or something like that. So here you are getting it. So this is by reflection. Whereas here we have a convex mirror. This convex mirror, this side convex. So this is the reflecting surface. So always the image is diminished at any position of the object in a convex mirror. And let us try to catch image formed by the convex mirror. So if you see, you don't get any image formed by the mirror, convex mirror, by reflection. It always forms a virtual image, that is, image is seen in the mirror itself. So this is convex mirror. Now here is a lens. So a lens will form image by refraction. So here you see it is bulging at the center and becomes thinner at the edges. A lens forms image by refraction. So let us see the image formed. See, you can see that image. So image of distant object. So that distant object image can be seen. Okay. So like this also. Right. Now here is another lens. So this is a concave lens. So at the center it is thinner, and at the edges, if you see, it is thick. So let us try to form image by using this lens. Now you are not getting any image of the object, only some light. So this also forms always virtual image. You cannot get real image using a concave lens. So what is the difference between a lens and a mirror? A mirror forms image by reflection process, and a lens forms image by refraction. So we are going to study about these optical instruments, and also we are going to study about how the image is formed by a prism. So prism will have two inclined surfaces. These are the refracting surfaces, and one is base. These two are the refracting surfaces, and we are going to study how this forms image by refraction. Now let us come to some definitions. So that is, here there are some important terms about which you are supposed to know. What is pole? In the case of a mirror, the geometrical center of the mirror, we call it as pole. Whereas in the case of the geometrical center is known as optical center. Now here I have taken a concave mirror. This is the reflecting part. So here the rays get reflected from this surface. Now I have considered a parallel ray. So to this PC, which we call it as the principal axis. And another term we have to know is about the center of curvature. If you observe, the mirror surface appears curved. So this is a part of a circle. You can imagine. Actually, it's something like a hollow sphere, of which this is a part. The center of the sphere is called as the center of curvature. Now, the line joining the pole of the mirror and the center of curvature is known as principal axis. Okay. Whereas in the case of a lens, we can observe lens has two curved surfaces. So one is this, the other is this. So it is something like two spheres intersecting. So it is somewhat like an intersection of two circles or two spherical surfaces, and thereby we get a lens formed. So the center of, actually it will have two centers of curvature. One is due to this curved surface, another is due to this curved surface, like this. So the line joining these two centers of curvature is known as axis of the lens. And now let us come into this. Another important term you are supposed to know is what is the radius of curvature. So the radius of the sphere of which the mirror is a part is called radius of curvature. Similarly, here it has two radii, R1 and R2. So one surface has one radius, the other surface has another radius. Generally, we use lenses of equal radii of curvature. So generally that will be same. So what you have seen in the example, that is the lens I have shown, is equally curved. So the curvature is equal. So radii of curvature is equal. So in the case, another term you are supposed to know is principal focus. So in case of a mirror, the parallel rays to the axis after reflection will pass through a point on the axis. That point is called principal focus. Whereas in the case of lens, so the parallel rays, in the case of a converging lens or a convex lens, they converge at a point on the axis. We call it as principal focus. Whereas in the case of a diverging lens or a concave lens, they appear to be diverging from a point on the axis. That is called principal focus in the case of a concave lens. So now another term is focal length. The distance from the pole to the principal focus of the mirror is called as focal length. So that is how we define. Here also, from the center of the lens or from the optical center to the focus, the distance is known as focal length. Similarly, we can define in the case of a convex mirror and also a concave lens. Okay, so that is about some important definitions. And another thing is, if you imagine a plane here passing through the focus perpendicular to the principal axis, so that plane on which the parallel rays of the reflection in the case of a concave mirror converge, that plane is known as focal plane. Similarly, we can define for lens also. Then another thing is about sign convention. While measuring the distances, in case of mirror, we measure all the distances from the pole, and in the case of a lens, we measure all the distances from the optical center. And the distances measured in the direction in which the actual ray travels. So we take the incident ray direction from the object as positive. So in that direction, if the distances measured are taken as positive, otherwise the distances measured in a direction opposite to the actual ray direction are taken as negative. So for example, here the rays are coming like this. So let us suppose here is some object, here is some object, let us suppose. So from the object the rays are coming like this, but you have to measure distance from P to O. So you are doing it in the opposite sense. So therefore object distance is taken as negative. Similarly, if the image is formed on the same side, on the object side, that image distance also will be negative. But whereas if you consider a lens, So the rays are coming like this, and they are getting focused at a point on the axis. So you measure the distance from the center to the point. So in that way, if you measure the distance, image distance, here the image, if it is found here, that will be positive because you are measuring the distance in the direction of the incident ray. But when you measure the distance of the object, again you will be coming in the opposite direction. So that object distance will be negative. So like this, if you measure the distances in the incident ray direction, take it as positive. If you measure the distances in the opposite direction, take it as negative. So in the case of mirrors from the pole, the distances are measured. In the case of lenses from the optical center, distances are measured. Then for the axis, if you are measuring the heights vertically upwards, positive, vertically downwards, the sign, the distances are taken as negative. So this is the sign convention we follow. So another important thing you are supposed to know while tracing the image formed by a mirror or a lens is the principles we have to follow while tracing the image of a point, either in the case of a mirror or in the case of a lens. One is the rays which are coming parallel to the principal axis and which are very near to the axis are called as paraxial rays. So these paraxial rays make very small angle with respect to the axis. So such they make very small angle at the pole. So or you can say they are very near to the axis. So after reflection, in the case of mirrors, they pass through the principal focus. So that is in the case of a concave mirror, the paraxial rays incident on the mirror after reflection will pass through the focus. In the case of convex mirror, they appear to be diverging from a point on the, that is principal focus of the mirror. That is in the case of a convex mirror. Then in the case of a lens, the parallel rays incident on the lens will converge after refraction at the focus, or it will pass through the focus. That is one important principle. Another thing is a ray passing, let us suppose if this is the object, a ray is passing through the focus. After reflection, it will pass parallel to the principal axis. So after reflection, the ray coming through the focus will pass parallel to the axis. That is another rule. And similarly here also we can say that a ray coming through the focus from the object, let us suppose, after refraction will pass parallel to the axis, something like that. Okay. Another rule is any ray, let us suppose here is the object. So a ray coming from the point, if it passes through the center of curvature, it will pass through the same point of reflection, because center of curvature is nothing but, say let us suppose this is circle, so this is the center, or this is center of curvature, and here is this. So any line will be perpendicular to the tangent drawn at that point. Any line passing through the center of curvature will be perpendicular to the tangent drawn at the point on the surface of the circle or sphere. Hence, therefore, the rays coming through the center of curvature falling on the concave mirror after reflection will pass through the same point. So these are the important principles which we have to use to trace the image. And another thing is, in the case of convex mirror, depending upon the position of the object, we may get real image or virtual image. Similarly, in the case of a lens, we may get a real image or virtual image, depends on the object position from the mirror or lens. Whereas in the case of a convex mirror or a concave lens, always we get virtual image. A virtual image is one which you cannot catch it on a screen. And to trace the image of a point, you require at least two reflected rays. So the point where the two reflected rays meet, so that will be the image of the point from which the rays are drawn. So you can have many number of rays, but it is enough if we draw only two rays from a point of the object to find out where the image is. So the locus of all such images of the points will give the final image of the object. So using these principles, we are going to locate trace the image of object, and we are going to derive some formulas regarding the mirrors and lenses.